In this video, we are going to look at access modifiers and how using different access modifiers affects the functionality of code. To begin, let's look at a statement within the Java docs about access modifiers. Looking here, we see, when you write a class, you need to decide what access level every member variable and every method in your class should have. Now, in previous videos, we have not given access levels much thought, and that is simply because I did not want to overwhelm or distract from the topics each other video was focused on, as access modifiers can alone be a challenging topic to grasp. From here on out, we are going to always consider access levels when defining member variables and methods because determining access levels happens to be a crucial part of object-oriented programming, and therefore a crucial part to the Java programming language. So without further ado, let's dig into access modifiers. We're going to look at the inheritance example used in the previous video. Right off the bat, we can see the access modifier public is used up here in the class declaration as well as on all methods of this class. Instead of public, which allows the member to be accessed anywhere in the program, we could have used protected, which allows the members to be accessed only by classes within the same package or through a child class, private, which limits access to within the same class, or even no access modifier, like the member variables here, which assume a default access level, which limits access to within the same package. Let's get a look at some examples of these modifiers to get a better understanding on the access level each provides. Looking at the two string variables here, we can see that no access modifier is used. Therefore, these variables assume a default access level, which is called package private, meaning the variables can only be accessed within the package in which they are declared. Looking here in the Project Explorer, we see there is only one package at the moment, called first package. Therefore, if we go over to the school class, where the main method is, we can instantiate a person object and access the name variable directly, since the school class and the person class are within the same package. We can also access the address variable directly, since currently there is no access modifier used here, meaning it has a default access level of package private as well. We can also go into the student class, a class that inherits from the person class, and write a method that manipulates the name variable directly, like such. This is possible because the student class and the person class are within the same package, which is first package. Now let's create a second package by right-clicking on the src folder, hovering over new, and selecting package. We will call this package second package. And within this package, we will create another student class called student2. Now let's try to set the value of the name variable in the same manner we just did in the student class of the first package. Notice we get an error that reads, the field person.name is not visible. Also notice one quick fix is to change the visibility. Therefore, since no access modifier was used on either of these string variables, their visibility was defaulted to package private, once again meaning the variables can only be accessed directly within the package in which they are declared, as we just seen. Now let's go ahead and use the access modifier public on the string variable name. Remembering the access modifier public allows the member in which it is used on to be accessed anywhere in the program, we can see that the variable name is not only directly accessible within the school and student classes in the first package, it is also now accessible from the student2 class of the second package. And since the address variable of the person class is still package private, we can access it directly within the same package like within the school class or the student class. But when we try to access it within the student2 class outside of the first package, we will still get an error. However, if we change the access modifier here to public as well, just like the string variable name, which we assigned an access modifier of public to, the string variable address will now also be accessible throughout both packages. Note that the effects of access modifiers also apply to methods. For example, if we look at the getName method of the person class, we see the access modifier public is used. Once again, this means the method can be accessed throughout the program. So we can use it here in the school class of the first package, in the student class of the first package, as well as in the student2 class of the second package. However, if we remove the access modifier and default the getName method to package private, like such, we get an error in the student2 class of the second package, while the method still works from student and school classes within the first package, the same package in which the person class is defined. Alright, so now that the default access modifier and the public access modifier have been covered, let's talk about the two remaining access modifiers, protected and private. First, we'll look at protected. Once again, protected allows the members to be accessed only by classes within the same package or through a child class. What that means is, if we add the access modifier to this getName method within the person class, not only will the getName method still be accessible from within the school and student classes of the first package, the getName method will also now be accessible through the student2 class of the second package. The reason it is accessible outside of the first package is because this student2 class is a child class of the person class, as we can see here in the use of extends person. Therefore, in changing the access modifier to protected, the getName method is now accessible within the same package in which the person class lives, as well as within classes that inherit from the person class. Lastly, let's look at the access modifier private. As mentioned, this access modifier limits access to within the same class. To understand this better, let's change the access modifier of the string variable name in the person class to private. We can see as soon as we do that, we immediately get errors on all the other files within the program. That is because in each of these files, we are trying to access the string variable name directly, and now that the access modifier has been changed to private, we get the error, the field person.name is not visible. This field is not visible because private members can only be accessed from the same class, meaning within the person class itself. So even though the student and school class are both within the same package, they are different classes, and therefore do not have direct access to the string variable name. And the student2 class is not only another class, but also lives within another package, meaning the string variable name will not be directly accessible from this class either. However, if we take another look at the person class, we can see that all direct references to the string variable name do work, and that is because these references are all made within the same class, the person class. Now that access modifiers have been covered, you may be wondering which to use in designing classes. While this decision is best made on a class-to-class basis, it's generally good practice to make instant variables private, like such, and use public getter and setter methods to manipulate or retrieve the values of them. This practice is known as encapsulation, which occurs when hiding internal state and requiring all interaction to be performed through an object's methods. With that in mind, we can look at the Java docs once more for a basic rule of thumb. As we can see here, use the most restrictive access level that makes sense for a particular member. Use private unless you have a good reason not to.